Hey YouTube, welcome back. What is failover mechanisms and what it used? Failover mechanism refers to the process of automatically switching to a backup or standby system when a primary system fails or becomes unavailable. It ensures that a system continues to operate smoothly with minimal interruption in case of failure. Failover mechanisms are designed to maintain the availability, reliability, and performance of critical systems by providing redundancy and seamless transitions between primary and backup systems. Failover typically involves automatic process that detect failures, reroute traffic, or initiate backup systems without requiring manual intervention. It is commonly used in systems where high availability and fault tolerance are critical. Let's take an example in how does it work. Let's say that we have a client and this client trying to send requests to a load balancer. Let's say this is a load balancer. And the load balancer will send the request to the server. Let's call this server 1. And the server will interact with the database. Okay, let's say that we have only one server right now. And this server failed. So we need to have a failover mechanism to handle this problem. So we can use a lot of different type of strategies or types of failover mechanism. We can use active passive failover. In this setup, the primary system is active, handles all the operation, while a secondary system, which is passive, remain in the ideal but ready to take over. So in the active passive failover, we will have another server with S2 that will take over and take requests from the load balancer in case of server 1 failed. When server 1 failed, S2 will try to take the request and try to take all the responsibilities of S1. There is other failover mechanism which is active failover, which in this setup both systems or multiple systems are active and share the load. If one system failed, the remaining systems continue to handle the traffic without interruption. So if we have S2, we send it the request, we have S1 and S2 which working together. So when S1 is failing, S2 is continue to operate with no problem. There are manual failover, and some systems failover requires manual intervention by administrator to switch to the backup system, like an application where automated failover is not configured and administrator must manually promote a backup database to become the primary database after failure. There is also a cold failover, like in this setup, the backup system is turned off or in a stale state and is only activated in the event of failure. And this one looks quite similar to the active passive failover. There is a geographic failover, which is disaster recovery failover. So in geographic distribution system, failover occurs between data centers or regions. If one region or data center experience a failover or a failure, another geographic distant location takes over. So let's say that this is not a server, it's a whole region. Let's say that there is no databases here anymore. Let's delete everything. So if we have like a load balancer and we have two regions, one which is the DE region for Germany, Deutschland, and it has like its servers that it's connected with databases, and we have message queues and everything here. And the load balancer is sending here, and we will have another, for example, another data center. Let's call it FR for France, and also it will have the server and database, and also we synchronize all the data or replicate all the data of DE in FR, and we duplicate all the data in FR and DE. So we'll make sure that when the full data center of Germany, if the full data center of Germany failed, the data center of France could take over all the routes for France and for Germany. So a web application hosted in multiple, for example, AWS regions or Google Cloud regions, if one region experiences an outage, the traffic will be redirected to the another region, which is France for this one. So we need to talk about the components of failover mechanisms. The components of failover mechanism, we have maybe, I would say, 4 main components. The first one is monitoring. Monitoring and health checks as well. So systems regularly monitor the health of primary and backup systems or backup components. The health checks mainly detect the failure, performance degradation, or system unavailable. So the health check mainly, for example, if we have a load balancer and this load balancer is trying to send requests to the server 1 and server 2, the health check will make sure if server 1 is available and if server 2 is actually available. So this is how actually we know if there is a server is failed or not. We send a health check requests and we get responses for them. And there are other strategies to handle this, like a heartbeat or something like that. But this is beyond the purpose of this video. Number 2, we have like a failover decision logic. The failover decision logic, like DL. The logic determines when to initiate failover based on health checks or failure conditions. Like this logic can be based on thresholds like response time, systems errors, or availability. Like a cloud service decides to switch to backup instance when a CPU usage, for example, exceeded 90%, or maybe a load balancer will make sure that it will not send requests to a specific server if this server doesn't respond to any health check requests at all. There are a third thing, which is a redundant system. So the failover process requires backup systems like servers, databases, network devices that are either idle or running in parallel to take over operations in the event of failure. An example for that, like in a cloud environment, multiple instances of web applications are hosted across different availability zones to provide redundancy, for example. You'll find this practice is used a lot in AWS, and there is something called AWS, I guess was availability regions or availability zones. Yeah, availability zones that was used in this one. There are the fourth thing will be the failback. Like after primary system is restored, failback mechanisms allow the system to revert to the primary configuration. A failback may be automatic or require manual intervention. Some application doesn't even have a failback, since if the other components are really identical, like 100% identical, so there is no need to go failback at all. So let's talk about where do we use the failover. The first thing that we talk about, which is the web servers. It will use a lot in web servers, like failover is widely used in web server environments. to ensure that websites remain accessible. It is used in databases, cloud computing, network infrastructure, and load balancers, especially load balancers, because load balancers use failover to route traffic to healthy servers, and we use like health check for that, and to remove the unavailable servers from the server pool. The benefits that come with the failover mechanism, I guess it will be quite similar to the redundant video that we did, because they provide the same thing, which is the first thing will be high availability. Um, okay. So failover mechanisms ensure that systems remain available and operational even during hardware failure or unexpected outage. Also, fault tolerance. Let's make it 50. So by providing redundancy and automatic switching to backup systems, failover mechanism makes system fault tolerance, meaning that they withstand and recover from failures without significant disruption. And in conclusion, like if we're talking about failover mechanisms and redundancy, they look like they are quite best friends. They always come together. If you have a redundant system, of course you have a failover mechanism. And if you have a failover mechanism, you satisfy what redundancy is. You satisfy the needs of redundancy. You provide a redundant behavior in your system. It's also, it's since it's provide high availability, it's minimize downtime. So failover mechanism reduce systems downtime by providing fast recovery when a primary system fails. Also, it improve the user experience, and also we guarantee the business continuity. Also, since failover mechanism, as we said before, since the failover mechanism, it looks like a best friend of redundancy. It has the same considerations when it comes first to cost. So as in our previous example, in this example here, where is our example? Yeah, here. We have multiple data centers, or we have multiple servers. So we use multiple components, and we want to make sure that one components will take the work of other ones if this one failed. So implementing failover mechanism, especially active configuration, can be quite expensive due to the need for redundant hardware infrastructure and licensing. It's really complex. Like set up and managing failover mechanisms can be really complex, especially in large scale or distributed environments where synchronization, data replication, and feed and failback process need to be carefully managed. Latency, since some failover sets up like a cold failover, there are maybe we have notable delay in switching to backup systems. There are data consistency problem, since we have two. For example, in this example, let me just delete this one. In this example, when we have two data centers, let me delete this as well. When we have two data centers and we synchronize all the data between both of them, we might get some data inconsistency. So in distributed systems or databases, ensuring data consistency between the primary and the backup system can be really challenging. In conclusion, failover mechanisms are essential for creating fault tolerance and highly available systems. They ensure that services can continue to operate during failures by automatically switching to backup systems, whether it's servers, databases, networks, or entire data centers. Implementing failover mechanisms improve systems reliability, minimize downtime, and support business continuity, especially in critical applications like cloud infrastructure and financial services. However, failover must be planned, configured, and tested to ensure effectiveness and avoid potential challenges like cost and complexity. So that's it for this video, and see you in the future.